Welcome to a new lesson on HDFS concepts. In this lesson, we would look at the new features added in Hadoop 2.3 release, that is HDFS Federation and High Availability. Let us start with HDFS Federation. This feature is added in order to balance the load on name node as the cluster size increases. Let us understand this with an example. Let us say there is a directory tree structure root, and under it are two folders, folder 1 and folder 2. And let us assume that there are a lot of files under it. As the cluster size increases, the name node has to store more information pertaining to blocks in its main memory. So for cluster with high number of nodes in the range of 2000, the limiting factor for scaling. Under Federation, a new name node can be added and the file tree structures and the block pool can be divided between the name nodes. Thus, each name node has to manage only the pool of blocks it is associated with and not the complete pool, thus reducing the load on a name node. It is to be observed that the same data node can be associated to different name nodes at the same time, and the failure of one name node won't affect the other name node. For example, if name node 2 goes down, the files in folder 1 would still be accessible. Let us just look at the key points we have discussed. HDFS Federation addresses the limitation of name node's memory to scalability. Each name node would be responsible for a namespace volume and a block pool. Data nodes can be associated with multiple name nodes. Name nodes won't communicate with each other, and failure of one won't affect the other. Let us look at the next feature, high availability. This feature is to address the time taken to come back to the stable state in case of name node failure. As we have already seen that the name node is single point of failure and it takes around 30 minutes of time to come back to the stable state after its failure. So to address this, a name node is always running on standby. The primary name node and the standby name node share the namespace and edit logs via highly available NFS storage mount. In future releases, Zookeeper would be used to transition from primary to the standby one. In this setup, the data nodes are configured to send reports to both the name nodes. In this case, if the primary name node fails, the standby can take over very quickly. In practice, it takes around a few minutes for this failover transition to happen. In this setup, it is important for the standby to wait to confirm that the primary has gone down. There can be a situation where the primary might not have been completely down but just a little slow to respond. In that case, there can be two active primary nodes and thus cause corruption and chaos. So to avoid such a scenario, the reserve node fences the primary node when it takes over. Fencing means that the standby would kill the name node process, revoke shared access, and disable the network port of the previous primary node. In certain situations, it goes to an extent that it cuts the previously active name node from the power supply itself. This is often called as stunit, shoot the other node in head. As you can imagine, naming this standby node as the secondary name node would have been apt, but there is a naming mistake that has happened. This wraps up our discussion for high availability. For a quick revision of key points on the slide, please pause the video now.